Hi everyone and welcome to this video on Venn diagrams and the addition rule. I'm just going to get straight into this because there's quite a bit to get through, so hopefully the video won't go for too long, but we'll just see how we go. So to begin with, what I'm going to talk about are a few of the special regions that we can get on a Venn diagram, and they are namely the intersection and the union. So in this first Venn diagram, I'm going to shade in A intersection B. Okay, now this symbol here means intersection and is essentially and. So it's where we have A and B together. And if I just do this in two different colors, so if we call this circle here A and this circle over here B, then if I shade in A, it's going to be all of this area here, including the bit in the middle. If I shade in all of B, it's going to be all of this area here. And so you can see that the areas where they overlap are clearly this region in the middle here. And so I'm just going to get rid of the other parts where they are not overlapping. There's that part gone, and over here we've got the other part gone. So that region in the middle there, that is where we have A intersection B. Alternatively, we could have A union B. So this symbol here means union and essentially means or. So again, I'm going to shade in two regions. So here's A and here's B. One or the other, so that is the entire region that I've just shaded in there. So it is the entire Venn diagram, excluding the parts around the circles. Now, how you choose to remember that, it's really up to you. I kind of think that this symbol here for the intersection looks a bit like an A for and this one here looks like a U for union. So that could be your way of remembering it as well. If I want to do a slightly more complicated region, for example, I had something like A intersection B dash. By the way, I should have actually labelled these A and B. That was a bit slack of me, but I'll do the same over here. So A and B to begin with. So in this I'm mentioning B dash, and I've mentioned it just down here as well. So B dash means the complement of B, or in this case, like we could think of it as being not B. Okay, so if I shade in A, well, that's this circle here. And if I shade in B dash, remember that's not B, well, that's going to be this part here. Notice I'm avoiding the middle section because that's part of B. We also have this region around the outside. And so when I want to do the intersection of these, I'm looking for where the two regions overlap, and that's clearly where the red and black are there together. So I'm just going to get rid of this part in the middle here because that's not where it's overlapping, and also around the outside of the shape we don't have any overlap. So I'm just being a little bit careful here because I could potentially write out my border. So there we go. So that would be the region that is A and not B. Now, we also need to look at mutually exclusive events. So mutually exclusive events are ones that have no overlap. And so we could actually draw the Venn diagram much like this one here, where the circles are just two completely separate circles. They don't have that region overlapping in the middle. Another name for mutually exclusive events is disjoint events. Okay. I'll just add that in here. So yeah, that's just something to be aware of. Sometimes we can draw Venn diagrams that way. Let's have a look at a quick example of the type of problem that we might encounter. So draw the following sets in a Venn diagram and find the probability of A intersection B, A union B, or B intersection A dash. So B and not A. This symbol here means the universal set. So that is the whole set And a few features to a Venn diagram that are quite important. So you need to have the circles, obviously. We also have to have a rectangle around it. You'll notice that I had the rectangle around all of mine. That rectangle represents the universal set. So anyway, I'm going to just jump into this. So I'll label the circles A and B. I'm also going to include, just up the top here, the number of elements in the universal set is, and we can see there are 10 numbers down here. So the number is 10. Then in the set B, I've got 2, 3, 5, 7. In the set A, I've got 2, 4, 6, 8, 10. So the only number that's overlapping there would be 2. That can go into this middle region. In B, we're still going to have 3, 5, and 7. And in A, we're still going to have 4, 6, 8, and 10. The thing is that there are some numbers in the universal set that aren't included in either of those. So I'll write them around the outside. So we're going to have 1. 2 is in there, 3 is there, 4, 5, 6, 7, 8, also 9. So those two numbers don't fit into any of the sets. So lastly, we need to evaluate these probabilities. So the probability of A intersection B, remember that A intersection B is the overlap, it's this region right here. Okay? And we only have one number in there, so the probability of that is 1 out of the total of 10 numbers. The probability of A union B, you might remember A union B was the whole 2 circles that we saw right here. So we have 8 numbers there out of the 10 total, and so I can just write 8 out of 10, which would simplify to 4/5. The last one, B intersection A dash. So we saw up here what A intersection B dash looks like. So you might think, well, B intersection A dash is just the other part of it. So where B intersects with not A, and it's this region just in here. It's essentially B only. And so we have 3 numbers there, meaning that our probability is 3 out of the total of 10 numbers. If we continue on, we have the addition rule. Okay, so this is a rule which I would say is quite important in both Year 11 and Year 12 methods. And it's all just based on a Venn diagram. So if we label this A and B, we can actually develop the rule for it here. Now, the rule is for the probability of A union B. So looking at what we did earlier, our process was we said, well, A union B is just all of these 2 circles here. So to figure that out, what we could actually do is we could start off by going, well, if we take this whole circle here, so that's the probability of A, and we take this whole circle here, so that's the probability of B, then we've got a pretty good rule for it. But the problem is that we've actually counted this region in the middle here twice. You can see it shaded in both colours. And so I need to get rid of one of the sections of that. So I'm just going to minus the intersection of the 2 events. So this here is the addition rule. Okay? And we can use that to figure out all kinds of probabilities. So we get a problem like this one down here. If one card is chosen at random from a deck of cards, what is the probability of it being a king or a spade? So we could think of K being the event getting a king and S being the event getting a spade. Then we could say the probability of K union S. So notice here that they use the word or. That tells me that I'm using a union. And that's going to be the probability of getting a king plus the probability of getting a spade, and then minus the probability of getting a king intersection with a spade, which actually means the king of spades. So in this case, the probability of getting a king, well, there are 4 kings in a deck of 52 playing cards. The number of spades in a deck of playing cards, well, there's the 4 suits, so we're going to have 13 out of the 52 cards. And then minus the probability of getting king and spade, or intersection spade, which, as I said, is just the king of spades. So that is just 1 card out of the 52. And we end up with 16 out of 52. which you could simplify to 4 out of 13. So that's all there really is for this. Something that I will also share with you is that you could use your calculator to set up an E activity for the addition rule. So I'm just going to set that up quickly on my calculator here. Now, what you can do is you can go into E activity from the main menu. I've got a heap here. You won't have all those unless you've already made a heap. But if I just go insert strip to and then numSolve, this is going to give me a number solve strip, which means that I can write in some kind of rule and then be able to calculate different things based on that. So what I'm going to do is just bring up the keyboard, go into ABC, and I'm just going to type this on my computer, but you'll have to type this all in from your keyboard there, but just PRA, and then I want to do the union symbol. So to get that, I go into math, I scroll down once, twice, and there's the union symbol right there. And then uppercase B, which you get by going back to the keyboard. Sorry, it's just under ABC. Obviously you can make your uppercases by clicking that button there. And that's equal to the probability of A plus the probability of B minus the probability of A intersection B. So again, got to go back to math, and there's the intersection symbol, and I'll put the B there. You'll notice that I haven't included any brackets around the A's, B's, or intersections and unions. The thing is there that if we did that, the calculator would think that it's multiplying, and it would give us more variables than what we actually need. So we have to just kind of write it in this way. But if you just hit execute now, then we can see this. Now this is already based on one that I had set up earlier. But if we want to do a question like this, now all we need to do is type in our probability. So the probability of getting the king before was 4 out of 52. The probability of getting a spade was 13 out of 52. And the probability of the intersection of the two was just 1 out of 52. And I can hit the solve button and it'll tell me the answer. Obviously it gives a decimal answer, but it should be equivalent. So depending on the situation, if you have a question where it is giving a decimal, giving you the option of writing your answer as a decimal, then this is a really good option for something like that. And the great thing here is that if we want to find one of the other numbers, so let's say we want to find the value of the intersection, then we can just change the one that we're looking for, and we might have probability of A being 0.5, probability of B, I might make that 0.6, let's just see how this goes, and the union can be 0.8. Is this going to work? Yep, okay, so the probability of the intersection then was 0.3. So it worked out quite nicely. And so, yeah, again, we can use this to evaluate problems in lots of different ways. Anyway, I'm going to leave the video there. So we'll see you next time.